Today we will be checking out the questions on 2D DP, right? So first question will be, let's say first check out this. Let's say we are having some 2D array and we need to apply the DP, that is dynamic programming, on this, right? On this. What is DP basically? DP basically is a method in which we are not calculating the same input result again and again. We will be using the results from the DP, that means the saved result. If we calculated for some input, we will save the result and we will be using that result again and again instead of finding the result again, right? So basically our time complexity will be reduced, right? So yesterday we have seen the questions on 1D. Today we will see the 2D, right? So first question is minimum path, that is this one, right? We are given m into n grid filled with non-negative numbers. Find a path from top left to bottom right with minimum sum of all the numbers along its path, right? Let's copy this. So we are given the grid, the 2D array, right? And we need to find a path with the minimum sum. This is the question. We need to find the minimum path sum with the minimum sum of all the numbers, right? So basically this is the path. This is the path with minimum sum. It's what? 1 3 4 5 6 7. Total sum is 7, right? This is the smallest or minimum sum, right? So how can we do this? So what can be the step? Let's say first approach will be the recursion with memoization, correct? So we will be calling the recursive function again and again and store the result in DP, correct? So what is the approach? Let's say what is the intuition for every cell I and j. So this will be the, let's say this is the cell, this will be having some value I and j, correct? You can either go come from top or come from left. Let's say we are at here, right? Now what are the ways to come here? Either we can come from up, either we can come from this left, right? Two ways are there. So two ways are there, correct? So we know now two ways are there, either from the top or from the left, right? What's next? So this is the formula. Okay, so I am saying we are having a bigger problem, right? We are at this point and now we will go in the depth, find for the smallest first, then come back, right? As we did in the recursion, right? So let's say we need to find the minimum path sum for, what is this, n minus 1 m minus 1, correct? So m minus 1 n minus 1, we need to find the minimum path sum at this point. This is the last point, correct? We need to find the sum, that is 7, right? Now I am saying there will be, for reaching this there will be two ways, that is the top or the left, correct? What is the formula for this? The left one, we will call same function mps, right? And what is the sum, what is the value? It will be what? If we are at I index, the left one will be, I will be same j minus 1, right? J minus 1 for the left one. And for the top, what it will be? It will be I minus 1, j will be same, correct? This is the top, this will be the index for this, I minus 1 and j, right? And for the left, the row will be same, only we are going back for the column, this one, right? That is j minus 1. Got it? The left and the top, right? I am saying for reaching any point there will be two ways, either from the top, either from the left. So we are having the bigger problem. we will be saying for reaching this, we will either come from the top, either come from the left. So we will be calculating the sum for the left and for the top, and same for this point. Again, for this to reach to this point, we will either come from left or the top. Same with every cell, right? So what we will do, we will be calling this, that is, let's say we are having I and j, I was at this point m minus 1 and j is n minus 1, correct? So we will be calling for here, this is top, so I will be same, no, I will be minus 1, j will be same, correct? And here we will be calling the previous element, right? Row will be same and j minus 1, correct? And we will take the maximum of both, right, from top and the left, right? If we are at this point, not the maximum, minimum, right? We need to find the minimum. If we are at this point, we will take the minimum, right? Of course we need to find the minimum path sum, so we will take the minimum of this one and this one, right? Let's say the total sum till now is 10 here, and total sum till now is 8, or let's say 6, right? So we will obviously take the smaller one, 6, right? So we will take the minimum, so minimum of both, right? So when it will go up, we will take the minimum of both, right? And again, same with this, we will be having one top, one left, right? And here what we will do, MSP we will call same for the previous row and the same column, same row and the previous column, right? And same for this. Now one more thing, when it will go up, we will add the, what we will add, we will add the current element also, grid I plus and j, right? Because we need to add the sum, right? We need to add the sum, correct? So at each point we will be adding the this grid I and j, the current element, right? Plus, and when it will end, when this tree will end, when we will come at the, when I will be at 0 and j will be at 0, right? At this point we will be returning the first starting point, this one, right? Return 1. At this point, after this point, it will go up, right? So this will be our base condition, this will be the base condition, right? So it's simple, right? We just having the two conditions, as we are having in the 1D array. Here also we are having the two conditions, and we will be calling for the same, and we will be taking the minimum of both, right? So at each point we will take the minimum of top and the left. Shall we write the code? So we are having two conditions, the top and the left, and we will be taking the minimum, right? So let's write the code. So base condition was if, first let's say if I is less than 0 or j less than 0, then we will be returning the maximum value, that means infinite value, right? Integer dot max value. The base condition was if I equal to 0, the starting point, and j equal to 0, this is the starting point, return grid of 0 and 0, right? This is the base condition, got it? After that what is the condition? We will be using memoization. So first, and let's write the method first, let's say helper, okay? And in this, int I will be there, int j will be there, int grid will be there, 2D array. What else? dp, right? This is the recursive function, okay? So memoization will be there, so we will be checking if result is already calculated or not. So if dp of I and j not equal to -1, that means it's already calculated. We will return the stored answer. Return dp of I and j. Right. After that we need to calculate the top and left and return the minimum of both. So int top will be what? Same function, helper. Now row will be previous, right? I minus 1. J will be same, grid will be same, dp will be same. Now for the left, we are saying we need to check the row will be same. We need to check the previous element, that means I minus 1, grid and dp, right? After that we need to return the maximum of both, and we will store in the dp. Return dp I j will be equal to mat dot minimum, right? Not maximum, minimum. Up, not up, top and left, right? So this is the recursive function with memoization. Understood? What is the time complexity now? Time and space complexity. It is m into n, right? Of m into n is the time complexity, and space complexity will be of m into n plus of m into n, right? This is for this one for the dp, this one for the recursive stack. Now before proceeding to the second approach, that is the tabular form, we will first try to make the dp array of this, right? We will try to make the dp array. Okay, now I here, j here, 0. What is the given input? Okay, 0 1 2. What is the given input? 1 3 1. 1 5 1. 4 2 1. This is the input given, right? Now we will be storing the result. We will be storing the result in the dp. This is the dp, correct? Okay, so we are starting with what? We are starting with the last element, this one, right? It will call for this one and this one, correct? Again it will call for this one, for this one, for this one, for this one, right? So on. So ultimately we will get this grid 0 0 at the first. So it will be what? It will return dp when dp 0 0 will be 0. What is the value? 1, right? It will be 1, right? The starting point. So dp 0 0, this will be the last call of the recursion, right? 0 0 will be grid of 0. It will return the value and we will get the value here, right? 0 and 0, correct? After that, now here what is the maximum value? Here we can either take from the top, either take from the left. Top is not there, so we will take the left only, and we will add the current element, that is 1 plus 3 4. Got it? And same with this, up is not there, so we will add the value, that is 4 plus 1, that is 5, correct? We will take the last one, that is this one, correct? And then at this point what we will do? It will take the value of up. Left is not there, so what else we will do? 1 plus 1, we will take the value from here and we will add the 1, that is 2. And here again it will be what? Left is not there, we will take the value from up, that is what is the value? 4, so it will be 6, correct? Now here what will be the value? It will be minimum of both, right? The up and the left, right? It will be the minimum of both. What is the minimum? It's 2, right? And the current value is 5. So total will be 7, right? Total will be 7. Got it? And what about this value? It will take the minimum of both, that is 5, add the value, the current, that is 1. So we got 6. And what about here? The minimum is 6, right? Add the value 2, it's 8. And what about here? Minimum of both, that is 6, the value is 1. So 7. Ultimately we got the answer 7. Understood how we are filling this DP table? So try to understand using recursion. So we will be going back, and when we will get this value, the first value, that is this one, we will be coming back, fill this value, right, and this value, and so on, right? And as we are comparing the top and the left, taking the minimum, so that's what we are doing here. Clear, right? How we filled this DP table. Now what we are doing, we will start, we are at this point, right? We are at this point, and we are going to the smallest one, then coming back, right? Now in the tabular form, what we will do, we will be having the smaller results, and we will be using that to build the bigger problem, right? To build the bigger problem. So I can say in this type, this is the base condition, right? This is the smaller solution. So I can say dp of 0 0 will be grid of 0 0, right? So I can say this is the base condition. I will be using this to form the results, correct? Okay. Now what formula we will use? We will use the formula dp of I and j. Either we can come from the up or from the left, right? So we will be adding the current element, we need to add, right? Here also we are adding the elements, correct? If you see here also we are adding the element. So grid of ij plus, now math dot minimum of what? Of the top and the left, right? That is what? dp I minus 1, j will be same, this is the top element, and the left, the I will be same, the previous element, that is j minus 1, correct? That's what we are doing here. For finding this 7, what we are checking? The minimum of both, right? The left and the top, and we are adding the same current element, correct? That's why I built this dp, so that you can understand the logic, right? So we will be using this formula. Just simple. We will start from the 1 index, and we will be having the answers, right? Okay, let's write the code for this. So how we will start? Let's write it here. Okay, so first we will be having, let's say, length, and m will be the rows, that is grid dot length. The m will be there, sorry, n, the row, the columns, grid of row length, that will be the columns. After that dp will be there, 2d new int right. After that we will start the for loop. We will start iterating the variables. In this we will just traverse the elements, just we need to take care of these elements, right? These elements, because here top is not there, here left is not there, so we need to handle this condition. Int I equal to 0, I less than what? M I plus plus. For the second for loop, int j equal to 0, j less than n j plus plus, right? Now what else? What is the starting condition? What is the base condition? If I is equal to 0 and j is equal to 0, this will be the starting point, right? this is the starting point. So this is this element, right? This element. So we can say this is the starting point. Just give the value as it is. dp I and j will be equal to grade of I and j. Correct. We got the base condition. After that, in the else condition, what we need to find? Now we will find the up, we will find the down, and we will get the minimum of both, right? So int up. Now there is one condition, right? If this is a first row, this is this first row. Here for this element, what we will take? The up, we will take the infinite value, right? So that in the comparison we will get the left as smallest, right? Because top is not there, so we will take top as the infinite. Correct. So we will be having one condition. If I is equal to 0, then up will be infinite. Or we can also have ternary operator. Okay, so if I is what, equal to 0 or greater than 0, then dp, if it's greater than 0, then we can have the dp of what will be the value, the up, that is I minus 1, j will be same, right? Otherwise if it's equal to 0, we will take the infinite value dot max. I think it's correct, right? What we are doing, we are checking if I is greater than 0, then we will take the dp of I minus 1, that means the upper position. That means for this 8 we will be taking this 7, right? Correct. And same for the down, not down, the left, that will be same. If j is greater than 0, then take the previous element, row will be same, j minus 1. Otherwise take integer dot max value, right? So that we can get the minimum value from the top. Got it? After that we will be storing the value in dp, the minimum of both, plus we need to add this value, right? This is the formula. We will be adding the value grid of I and j plus math dot min up and left, right? And at the end we will be returning what, the last element, that is this element, right? It will be what, dp of m minus 1 and minus 1. Okay, so this is the solution for second, that is tabular form. Understood? So here you can use the different condition also. You can have the if else condition. If I is equal to 0, put the value from the top if it's greater than 0, right? Now the third form is space optimization. Right. So let's make this dp array again, 1, 4 and 5, I guess, then 6 here, 7 here, I think here also 7, here it was 2, 6, 8. Now for calculating this value, we are checking what, the previous value, this one, and the left value, right? Basically the top and the left, we are taking the minimum of them, right? Then we are getting this value, correct? And for this value, what we are checking? We are checking the top element, the top row, right? This is the top row, and the previous element from the same row, right? So for each element, what we are checking? We are checking the previous row element. So for each element, what we are checking? Let's say for 8, we are checking the element from the previous row, but the column is same, right? Previous row, column is same, right? And for the left element, what we are checking? We are checking the previous element, from the same row, previous column, right? Same thing we are doing here. For the up, we are taking dp I minus 1 and j, right? That is what, previous row, but the column is same, right? And for this also, for left also, what we are checking, the same row but the previous element, the previous column, right? So I can say this, right? For the top and the left element, previous row, column is same row, previous column, right? I can say this. In 1D array, what we are checking, we are checking two values, right? In the Fibonacci series, let's say we are having 0 1. For the next value, what we are checking, the previous two elements, right? Not the whole array. Here also we will be checking the previous row and the same row, previous row and previous column. Understood? So here we were using previous one and previous two instead of whole array, right? Here we will be using the previous row. So I will say, instead of using this 2D array, instead of using 2D array, we can only maintain a previous array, right? Maintain a previous 1D array, right? Because for each element we are just checking the previous row and the current row, right? And current row, right? Got it? This is important, right? So we got the intuition what we need to do for space optimization. Now we just need to code, right? How we can code, how we can modify this. So in the space optimization, we just need to reduce the space. So instead of 2D array, I will be using the 1D array. Okay, the previous row. So I will be using previous row equal to new int size will be what, column n, right? Because this is a row, it will be having n columns, right? What's next? Now for each row, for each, like we are going row by row, right? Let's say we are at this row. So for this row, we will be maintaining a current row also, right? Current row. So after this, we will add one condition, or let's write the new code only, then it will be mess. So what I'm saying, first we will be having this m and n will be same. We will be having one prev that is equal to new int n, right? After that we will start the for loop, int I equal to 0, I less than m, I plus plus. This is for the row. Now for each row we should maintain a current row also, right? So int current equal to new int n, right? So this will be a current row for each row. As we are going down, we will be having a current row for the current elements, right? After that we will be starting the j for loop equal to 0, j less than what, n, the columns, j plus plus. Now the base condition will be same. Yes, it will be same. If I equal to 0 and j equal to 0, then what we will do, now we will add the value in the current, right? In the current, this is the current row, right? So current of what, j is equal to what, grid of I and j, grid of I and j, right? So this is the base condition, this is the base condition, right? In the else condition, else if this is not the base condition, what we will do, now here what we are having, we will use the same condition, right? We will use the same thing, int up will be equal to same ternary operator, I is greater than 0, then it will take the value of, now dp, what is this value, what is this value, this is up, right? This is up. For the up we are using what, previous row and same column, right? You can see the indices, right? I minus 1, that means previous row and same column. So I will be using here the previous row, right? The previous row, that means previous of j, right? The column is same. Got it? How we are using the previous row. Instead of this, we will be using the previous row and the same column. Otherwise, the infinite value integer dot max value. Got it? And if it's a left, then what we are doing? Again, same ternary operator. We are checking if it's greater than 0. Then what we will take? We will take the value from the same row, right? This is the value. What is this? For the left, this is the value. What is this? This is basically same row but previous element, right? Previous column. So I can say I will take the element from the current row but the previous element, j minus 1. Otherwise this same thing, right? So understood this ternary operator. I explained this before also. So if this is a first row, this is a first row or the first column, right? Then then we should take the left value. For this we will be taking the left value. So for the top we will be taking the maximum, the infinite value, so that in the comparison with the minimum we should take the left one. Same with these ones. Correct? Got it? After that, the same thing, dp of ij. Now here what we will be doing? Current, right? We will be storing this in the current row which we are maintaining for the current elements, right? So we will be taking what? Grid of inj plus minimum of math dot min of up and the left. After that this else is completed, this for loop is completed, this one. After that, this, now we are having the filled current row. So now we will be moving to the next row, right? So let's store this current in the previous. For the next row, this current will be the previous row, right? So this is how we will complete all of the elements. I hope it's understood. So what we are doing, we are just maintaining the current row for this within this for loop, and we are using the up value from the previous row, right? And we are adding the value of this current minimum path sum in the current row. After that, we are modifying our pref, because for the next row this current will be the previous row. Now what is the time complexity here? Time will be same, right? Time will be of n only. We are iterating each and every element of the array, 2D array. It will be m into n, right? What about space? Space will be what we are using? We are using this pref. It will be of n, and we are using this current. Again it will be of n. So it will be of n. We can ignore the constant.